Hello everyone, welcome to this last little vignette on Chapter 9, Electrons and Atoms. I'm going to use this video to kind of review and hopefully solidify this concept to you of valence and core electrons. We introduced that when we talked about abbreviated electron configurations, and in abbreviated electron configurations we use the closest previous noble gas in brackets, and then wrote the rest of the electron configuration as we would for the full electron configuration. So we said that core electrons are the ones that are closest to the nucleus. They do not participate in bonding. Valence electrons, those are the ones that are furthest away from the nucleus. They have the highest, they are associated with the highest principal quantum number, and those are the electrons that are involved in bonding and reactions. So for selenium, for Se, if I was to ask you the number of valence electrons for that atom, looking at the full or abbreviated electron configuration, you should be able to see that there are a total of 2 plus 4 or 6 electrons that are associated with orbitals with the highest principal quantum number, specifically 4. So Se has a total of 6 valence electrons. Okay, so that's how many valence electrons Se has. If I was to ask how many valence electrons are in Y, looking at the abbreviated electron configuration, I see that there are 2 electrons associated with the highest principal quantum number, which is 5. So this element Y would have 2 valence electrons. So being able to determine how many valence electrons an element has is going to be really important when we get to the next chapter on chemical bonding, because those are the electrons, the valence electrons, those are the ones you are going to have to keep track of when drawing chemical structures and drawing chemical structures that are called Lewis dot structures. So these next 2 slides are just kind of showing you the difference between core and valence electrons. So silicon would have a total of 4 valence electrons, because those are the ones that are in the orbitals with the highest principal quantum number. The rest of the electrons would be core electrons. With selenium, again, just make sure that you use the valence electrons that are with the highest principal quantum number. There are some transition metals that are exceptions. We will not talk about those, so you don't need to worry about those. Primarily for this course, you need to be concerned about numbers of valence electrons for main group elements. So looking at your periodic table, elements that are in group 1, 2, 3 through 8. And what's nice about those elements is that those elements, the number of valence electrons is equal to their group number. The one exception is helium. We put helium as a noble gas in group A, but it only has 2 valence electrons. But all the other elements that are in main groups, meaning groups 1, 2, skip the middle transition metals, groups 3 through 8, their number of valence electrons is equal to their group number. So for example, for the alkali metals, things like hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, they're all in group 1. They all have 1 valence electron. Same thing for all the elements in group 2. Beryllium, magnesium, calcium, strontium, barium, radium, they're in group 2, they all have 2 valence electrons. Say the same thing for the noble gases, the halogens, things in group 6. I know it's not listed here, but elements in group 6, oxygen, sulfur, selenium, tellurium, polonium, liveronium, they're in group 6. They have 6 valence electrons. So I know I don't have a star here, but I think that it's a really important point to be able to determine quickly the number of valence electrons for representative elements or elements in groups. In general, elements in representative groups, the number of valence electrons is equal to their group number. That's a concept that's really, really important, and you're going to be needing to use that in the next chapter, which is chapter 10. But this is the final slide, final video for chapter 9.